Okay, so um, happy December, day two of this series. Um, so there's actually a lot that I was thinking about doing for today. Um, and I also just wanted to review or recap what I did yesterday, especially off camera. Um, so I mean, yesterday I posted the video of day one doing three leak codes, and then later in the day I worked on a school project that's due this week. Um, for the final project of my web programming class. So um, there's a few things I wanted to get to today. One was one of my partners on the team needs me to review a pull request. I also need to rip some of his code into mine and look at that. Also, I forgot today's the first day of advent of code. So I might look at that. I've never done advent of code before, so I don't know how hard it'll be or if I can do it. But it'll be interesting to look at it. And then a couple leak codes, and that's you know we see where the day takes us. But yeah, this week I have like I said, my web programming final project's done. Next week I have my discrete math final, and the week after that I have a project due for my How Computers Work class. Um, so yeah, lot to do. Um, so so um, I want to look. Actually, first I want to look at um, classmates PR. Uh, okay, that should be a good day. Um, so so he wanted me to review this. Um, bro, I do I not have a git ignore on this? Um, I guess I don't. Uh, let's add that real fast. Um, I do, and it doesn't have node modules. Okay, sick. Did I butcher that? Definitely did. It doesn't look right. Mod. No. Is that all? I don't know if it matters. Uh, Beautiful. Okay. Um, The only problem is this isn't fully fleshed out yet. So here, I'll make a little drawing. So we're working on this e-commerce app, right? And I'm working on like the cart, like Amazon has a cart. Any place where you buy stuff really has a cart. And um, okay, we can look at, let's say, wow, that's ugly. Uh, this is the screen, and then we have, these are all ugly. Let's just do this. So we have like this, a separator, and then we have like the cart items, right? And then this is the checkout. Where can you up the font? Can you? Whatever. Anyways, so this is the checkout button. These are like the things, right? So the idea is right now I have to, this is kind of cool. These elements, they need to be rendered in by the backend, right? So, um, so this is like the fetch, right? This is our fetch all cart items. There's also a like a save for later. How most sites have that. So um, so this also has to be fetched. So everything from save to later and cart needs to be fetched. Then we need our, creating cart items. So this is the one thing I also wanted to look at. Because right now, um, if we go through the flow of things and we go here, um, right now I have all these events, right? Where I have fetching all the items in cart, fetching all the saved items, removing items from the cart, um, sending an item to the save for later, sending something back to the cart, and then just an error. Um, yeah. There may even have to be something else here for editing quantity, but I can deal with that later. And so the idea is, right, that you have this render method, which is in our base component constructor. So it just requires that we have to have a render method. And so the render method um, um, the render method will, like right here, you see how I have like a new instance of virtual cart. Um, and so right now, usually this would be like the main marketplace page would be loaded in, and then the render method would add, it clear anything that has previously been in there, because if you want to switch a page or load the page, you want to remove what the last page was. And then we append whatever is the current view. And then also in our main file, I'm on this branch, but on our main file, it also appends afterwards the navigation bar for the website. And then you have the navigate function, which you call to in any component, so you can navigate to a new page with a button. But so this render method, we create a new element, give the class name of cart container, and then we create this inner HTML. We attach the event listeners to this, and then we return that. And so that will be rendered when it's called for. The event listeners, this is the same thing. So we have these events and Event Hub that we're subscribing to. If we go to the actual Event Hub, Um, you can see we're exporting the fetch, everything that I already defined up there, and these are all like the, you know, this is the constructor for if you want to subscribe, publish, or unsubscribe to an event. Um, so, so this, so when we do this attach event listeners, we're attaching all of these, and then we can attach these listeners uh, to the actual, you know, to the actual HTML elements. And so if you were to send a request, it would put it there. So a couple things I wanted to do was so Postman, so you can send requests without setting it up. Is I wanted to do a post because I haven't tried this yet. So if we look at if we go to the back end right now, my models, this is the cart model. So we're using SQLite and defining like kind of the data structure in this, which is subject to change, but for right now, that's how I have it. Um, and so this is my test data right now. So you can see if I do a request to the API for get, okay, I have nothing running. CD into the back end. So if I send a request, oh, I'm on post still. Why is this erroring? Oh, I don't have the front end running. Duh. CD download, CD Aquatica, CD front end, yum start. Okay, now I can do this. Should be able to do this. Okay, there we go. What was different here? Why? Okay. Anyways, so just the whole idea, I'll have this actually open onto my front end. Um, that way it's just easier to go back and forth. We also have these the services that go with the event hub. So like these are the actual things that are talking to the back end. These are the things that are um so like the API card is what we define. Um, back here using Express. Um, so yeah, anyways. So the whole idea here is just I have this cart page that is being rendered through the app component um, when called upon. There's a base component that you extend all these components, so you have a render and a load CSS method in the actual virtual cart. The page is I can actually show the page, but the oh my god. Um, uh, yeah. And so the idea is that right now I want to make sure that's working is that I can um so right now the get is like when I send this request it is getting, but right now obviously it's not rendering on this page, right? Um so you can see that it's failing to catch uh the items. So have to figure that out. Um I wonder if there's any logs in here. Okay. Course. I actually think on a older thing that I was working on, not service. Um, um, so I have cores here, but for some reason, wait, yeah. So the front end is hosted on localhost. I think I just don't do this, right? Um, uh, and the cart services. Well, it is. What's actually making the request here? Like, is this a port 8000? Don't think so. Um, I think I need to talk with my friend ChatGPT. I don't think doing um you have to think um uh, 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 um you have to think if this is working, right? Then the actual back end is working for getting the stuff that I want. But so that means that the services is the thing that's but that's weird because if I'm making a request. No, that's not weird. So it has to be something in here. I'm assuming it has to be with this base URL. Um, did I save? Still this. It has to be. I have to allow this on cores, right? I don't understand why I want to do that, to be honest. Um, what did he do for multiple po? Yeah, let me do this. Okay, I have to. But I do not care. I want. Uh, oh, backend's not on that port. Okay. Honestly, I think this would be HTTPS. But like cores, I'm not trying to allow my backend access to my backend. That would make no sense. Why does that ever work? Why does that ever work? How does cores allowing its own backend let this work? Okay. Okay. Yeah. Well, at least it's working. Um, so the thing I wanted to do, I will clean this up later. I want to get to other stuff this morning. But I got that working. Um, I'm just gonna commit these for now. Um, uh, uh, integrate cart page with backend. I have to follow a specific structure for these commits, so that's why I'm yapping. Um, Beautiful. Uh, now I want to check out main 2. Why wouldn't these be on with the last commit? What? Um, so there was a few things that I wanted to look at with his PR. He messaged me something. I'll check it later. I don't wanna. Um, so just run it. So pretty. Okay. Let's also um, beautiful. That logo is much better than it was. Okay. This whole thing should be clickable, but I failed to load data. See what that's all about. Not found API products, whatever. Let's check his routes. Um, no, this is the product model. Okay. There's product ID, name, seller ID, seller name, blah blah blah. So I should probably check on my code. I want to rip the product ID, the name, the price, and the description. Nothing else I need. Um, product type, image, and review. Okay. Initialize. Okay, so he does a try catch on authenticate and sync. He has a create function, product.create, product data. I'm guessing this is from here. Oh my God. I just want to see how he integrated the back end with. Routes, that's what I was looking for. I don't know why. Not order. Product. Okay. All products, specific product. Add a new products. Oh, dot post products. Okay. Okay. I mean, it looks fine. The only thing is, whoa. Okay. So that's the thing is I don't know why. Huh. I just want to figure this out. Once I can figure this out, I'll... So it has to be on the front end services, right? It's the same error I was getting, in a way. Um, I want retrieve a specific product. Wait. Where's this request coming from? The product page. Oh, what is going on here? Increase, decrease. I need to set this up as well, but for an event. Um, okay, so this was being logged. So it's trying to get API products product ID. Failed to catch product data. Okay. Well, let me look at, is this on? Yeah. Um, what did I want to look at here? His backend. Um, products ID. To get fetch API product ID is our response. So we're not getting a response from this. Why? Where's product ID? It's what we're passing through. And we are getting it. But then we go to failed to receive products. That's the route, right? So this is failing, and because this is failing, it's the same exact thing. I mean, if we can't receive all, we're not going to be able to receive that. But why? Um, What if I just tried this? Not what I wanted. I'm gonna ask ChatGPT. I don't know why, because I mean, it looks the same as like what I'm doing, right? After use, we have that as like a root, and then we go to product routes. In the routes, we have so API slash products is sending a request. I mean, I know this is working. I don't know actually know why I just tried to test that because I know this is working um because this is triggering. So it's this um in which is failing. I'm pretty sure this is going. This is front end. Oh wait, whoa, 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 whoa. What is going on here? I haven't worked with SQLite, so I actually don't know what is going on. Um, okay, a product model told me to do a SQL sync force. Or we are doing that. Okay. Cost product equals SQL. Fine. Product. He wants this. Okay. I mean, we already have. Already have that. Oh, wait. Okay, whatever. So does this actually say initializing? I just don't get SQLite. I honestly don't know what this code is even doing. I know we're defining the model of of a product, right? Same thing for a review, an image in the product type. Then we define relationships. we have a constructor for all of these that we defined. These are all our models. Then we await authentication of our SQL database and we sync it. And then we have these create, read, update, deletes. Right? But what we're trying to do right now is just trying to fetch the database. And it's not doing that. It's fine. Yeah, we're good. I want to see if the text on my screen was bad. Okay. Yeah, I literally have no idea what this could be. Um, like how everything is always like command line, and then Windows it's like download. Stuvie is good, but new window. Okay. What was the extension? Wait, what does he do? Oh, carts. Wait. He opens it. What? Oh shit. I mean, what? It's saying it's carts, not products. Wait, this is from me? When did I do this? I just realized is saved is the parameter I set up. When did I ever set up my? Do I have it set up? I actually might. Oh my God. What a goat. That's crazy. Okay. Okay, let's try doing um oh, weird. So like the carts thing is set up, the product one isn't. I mean, I guess let's go look at um actually let's just go look at what I was doing. So a SQL defined cart. Honestly, I just want to see. I'm using like I'm just gonna try this out. Um, and can go from there. Um, what? Include images reviewed. What changed? Everything looked the same to me. Maybe it was that. Look good. Get the fuck out my face. So this is product image review product type. These are the exact same thing, right? Just this is added. Was that even on there before? Okay. It's not model.read is not a function. Product controller.get all products. Let's try that now. Why wouldn't a wait work here? I think I'm just gonna rip it one for one then. It has to be some like, oh, you can't do an await, and because I mean, so like in my constructor, I just do a this dot initialize model. So honestly, right? And then when I do a this dot model, it's yeah, and then the product model, just make sure this is looking good. Um, I just do an await see data. Yeah, perfect. This initialize is not a function. Did I spell it wrong? Okay, I'm gonna crash out, bro. This dot model dot read is not a function. I see. I see. Fucking huge. Okay. Okay. So now I can just rip off um I can rip off this seed test data. Um, which should be, wait, that, and then check if database already has one. So I wonder in here now. Yup. Yup. Okay. Images, products, reviews. Beautiful, bro. Beautiful, beautiful. Nice. So is this rendering on the front end now? No. I mean, I'm sure if I do. Um, Pretty sure there's supposed to be a ID on all of these. Wait, where's the ID that I'm not seeing? Oh, it's randomly generated. Oops. Um, okay. So if this is working now. Give me services. Well, if we go to here, product not found. It has to be that just not in the back of the database. It literally, everything should be working out fine. Um, yeah, it doesn't exist. Yeah, let's add it. Is that what I did last time? Um, product model. Why isn't this updating? My backend is not running, so that wouldn't work. Damn, bruh. I think I'm just gonna move on from this because and send him a message because I shouldn't have to be putting this much time into his code. Um, I'm gonna message him real quick. I'll actually, I'm gonna have my screen. Okay. Okay, let's move on from that because that is just a fucking headache right now. Um, okay, let's look at admin of code. I remember checking out last year's, but okay. Which someone decides that the best place for them to check first would be the chief historian's office. Upon pouring into the office, everyone confirms that he's nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning he was doing before he left. Perhaps these notes can be determined for the search. Throughout the office, the historically significant locations are listed not by name but by a unique ID. To make sure you don't miss anything, the historians split into two groups, each searching the office, trying to clean their own complete list. There's just one problem. By holding up, it's clear that the lists aren't very similar. Whoa. Okay, so we have two lists. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list. I mean, I guess it would be stupid not to like try to solve this with code. Within each pair, figure out. So this is an example. Find the total distance between the left list and the right list. Add up the distances between all the pairs you found. Uh, I'm guessing it's, yeah. Okay, yeah, you definitely do this with code. Yeah. Okay. So, um, so what I want to do, actually, what I want to do is go here and add a new folder. We're just gonna make an admin of code folder. In here, we'll have day one. Um, and so I want two things. I want a data.json and a distance.py. Okay. So first I want this. Okay. 1,000 lines. And then this. Um, okay. So the whole idea here is going to be that's not how you do commenting in Python, is it? Yeah, that's it. Um, so first we want to sort um, both sides of the list. Um, so how do we? Well, if we look at the I mean, I just put it in there as like it's like a line, right? So the first line has two values, second line is blah blah blah. So how would we go about? I mean, I kind of would love like a list one and a list two. This might be wildly inefficient to do that, but um, I mean, I could just do something where I say like, okay, import JSON. Yep. With open data.json. Wow, that's literally what I named it. That's crazy. That's file. I haven't done this in a while. Data.json.load file. Can you then, can I print the data just like this? Um, oh, why does it hate this? I forgot you need to actually format JSON. Oh, you can do the same thing and just not use JSON. That's kind of sick. Um, did I do that? I did do that. Beautiful. So beautiful. Okay. Ah, yes, I remember now. I understand it now. Uh, numbers. So numbers is going to be equal to, what was it? Numbers dot split by a space. line.strip.split. Oh yeah, line.strip. Okay. So now we're gonna have now numbers at each times is going, so if we just print like numbers at 0, save this and run it, it should just be those first numbers, right? So 13, 630. It's gonna take a long time to scroll up. Is it 1,000, 10,000? Whatever. Hopefully it's the same. I mean, it should be. So we want to say for, what do we want to say? I mean, do we not just say like list 1? Count equals nothing. List 1 at count equals numbers 0. List 2 at count equals numbers at 1. Print print list 1, right? Okay. Distance, list distance. Can I just do this in this loop, right? Because I mean, if I have the first two numbers, I can just make like distance is going to be equal to numbers at 0. They say no, it's right minus the left. Oh, but I still have to sort these. Okay, no. We're going to do this. And afterwards, we're going to do a list 1 dot sort. List 1 equals Python sorted function. How do you declare this? Left list equals sorted list 1. Right list equals sorted list 2. Distant list equals, that should be a loop. This should be 4. Can I print off the length of the left list? Um, oh, I never. Also, I think this is list one dot append. And that is 1,000. That is what we want. Okay. So now I can just do a for I in the range of the length of the left list, right? I can just say um, distance list equals this difference, or I guess I can't do distance, is equal to left list at I, wait, no, right list minus left list at I, distance list dot append distance, print distance list also print uh, length of list, the length of the distance list. There's definitely a Python to int. If these two I'm assuming I either wrap the whole thing or just the I. The whole thing. Okay. Available for int with base 10. Wow, that's something. Why would that be spaces? If I print the left list, right? This might error because I have nothing in the loop. Um, Sorry. Oh, well, no, actually, that's what I want. Okay, maybe I shouldn't infinitely print yo. Okay. Um, so I mean, is left list at 0, not just like it is a value. Can I not turn that into an integer? So then why wouldn't this work? I'm actually still confused as to why this wouldn't work then. Ooh, you know what I could probably do? You know why this is freaking out? It's because I could just do um uh uh so this is still in the range of the length of left list. But what I can do is I can say like um left num is equal to left list at I, right? Right num equal to right list at I. And then I can say, okay, the distance is equal to an int of right num versus left num. And then distance to this, print distance list. What? How, bruh? I mean, does this go through? Yep, no errors there. Oh yeah, I could do a try catch. Try to do this. Why not that? Okay. I'm just gonna rip that. I mean, can I just not do just a catch? Oh, you got me. Wait, oh my God, I guarantee you that because I was lazy earlier. Wait. Is numbers at okay, can I like Jesus Christ. I'm just gonna delete that for now. And I just want to print list two. May have found the problem. Okay, yeah, I am just mm-hmm. integer of left list at I. Um, is it left list at I? I don't think so. I think it's God. It's right list. Then distance dot append, and then I can do Python sum list is, I know there's just a print the sum of distance list. Let me just make sure. You append both, sort both. Answer's too low. So the distance is the right minus the left. And then I append that. Can we just print the length of this? It should be 1,000. It is 1,000. Okay, let's print. Yep, first value is the lowest. How would this ever be wrong then? Why? I don't see any flaw with this. Ah, sorry about that. I had to pause the recording because my dad came in. So I don't understand. This shouldn't be sorting. No. Oh, this is funny that I still have this. like that. I mean, I'll just put it in here and see if there's any reason in the world. Bro, I hate Vim sometimes. Two two six one four three. Is that not what I put in beforehand? Let me make sure the last thing corresponds. I know there's a way to go in Vim to go all the way down. I know like GG goes all the way. Yeah, that lines up. I don't get how my logic isn't working, so I'm just gonna keep ripping code, which is probably horrible, but well, that's definitely different. That correct? What changed here? Two things open up. Yep. Sort both lists. Yep. Distance. Okay, let's go back. Let's go back. So this is what I had beforehand, and I'm like, how is this not working? Right? Is it literally just this? It was just using an ABS. Why? Weird, bruh. I'm gonna go to the bathroom real quick. I will be right back. Okay, I am back. Um, part two. Your analysis only confirmed what everyone feared. The two lists of IDs are indeed very different. The historians can't agree which group made the mistakes or how to read most of the chief's handwriting, but in the commotion, you notice an interesting detail. A lot of the IDs appear in both lists. Maybe the other numbers are. Figure out how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list. Wait. Adding up each number in the left list after multiplying it by the number times the number appears in the right list. Okay. Oh, okay, okay. I think what I'm gonna do is honestly, I'll just comment out all of this. Bro, I need to become more efficient with my I guarantee there's a way I can just easily comment out everything very quickly. I could just do this. I don't know. I'm doing a space. You know what? Every single line. Fuck it. Okay. So I want again my left list. Um, I mean, I guess and my right list. By the way, I never needed this count variable. And then with open, open data.txt, open in a read format as file. For each line in the file, we want numbers equal line dot strip dot split at 1, 2, 3 left list dot append numbers at 0 right list. Oh my god. Dot append numbers 1. Okay. Now those are populated. So now I want a for I, and actually I can just say left list, right? For value is better when you're doing this. For value in our left list, I want to check the amount of times it appears in the other list. So I want to take the value and I want to compare it to each value. So just a double for loop. So for the value in right list, value L, value R. If if the int of value L is equivalent to the int value R, then I want like a count to increase, right? I want actually each time I want occurrence to I'll just call it count. count equals 0 on count plus equals 1. Right? If they're equal, I want to increase the count. And then when I'm done, I want to say score equals value left times the count. And then I want total scores, this will be an array, and we'll say total scores dot append score. And then print total scores and print length of list. I'm at OG. Okay, something's wrong here. Oh yeah, that's because I'm saying for every single value, no matter what, I'm saying score equals, so no, I want it to be this, right? Although that doesn't look right. Why are there just so many blank entries and then crazy numbers? So for value L in left list, if that left value is equivalent to the right value, we increase the count. Else, you just continue. You should only ever, I mean, honestly, if score does not equal 0, oh my, I'm in Python, then append it. I'm trying to think. I have an outside loop that on this value it says count is this. And then I have an inside loop that does like increases the count as many times. And then it should be when I finish that loop, it'll go down and it'll say, okay, the score is going to be equal to int value L times count in its absolute value. That was definitely the error issue. Length of list is 33. We want to print the sum of that. Oh, I'm good. Wait, that was kind of cold. Day one. I wasn't cold, but that felt good. That ABS thing I'll use more. Like I wonder if I didn't put that there right then, would have been the same. Oh, it would have. Okay, never mind. But um, yeah, changing that to an int was very crucial. I still wonder on the last one why I needed it to be um an integer. Uh-huh. Sick. Okay. Now it's time for our favorite little bit of neat code. LRU cache. Okay. You give an array of integers nums containing n plus 1 integers. Each integer nums is in the range of 1 to n inclusive. Every integer appears exactly once, except for one integer that appears 2 or more times. Return that. Just find the duplicate. Okay. A brute force way of doing this. I'm guessing it just wants. O of n. I know I can do this in O of n plus n. Well, I know because it's weird. So if this was just an array, right? You would you could just convert it to a hash map and just see if any value is greater than 1 for a frequency map, right? Or I mean my brute force idea was taking the linked list, converting it to an array, and then just stepping through the array and being like a well, you know what? I think that'd just be the same thing with a like if we kept track of like um like scene values, right? Where this just holds every single value that we've seen. Like check if a value is in a list. It just is in, right? If 30 okay, so you just say the value in list, right? So if I step through this, I don't need to hold on to any values, so I can literally just do, I don't even have to make the copy. I can just say, for No, just while nums if nums dot val. Wait. Can I do a dot val? One second. Print nums dot val. Is this the still same structure that we've been running with? Nope. Whoa. I'm so confused right now. How am I able just to print a linked list? I'm so confused right now. While nums. Like, I can't do this, right? I can't do like a for I and nums print I, right? If I in scene values print or sorry, return I, else I dot or scene values dot append I. What the fuck was this? This isn't a list, is it? I mean, and then this is O of N, I'm pretty sure. Oh. Oh, that is true. Because you're scanning too. Okay. But how is this? Oh no, you were given an array of integers. Am I on the wrong thing? This has to be something like NeetCode put this in because of something like uh so how can I go through this in one sweep? Oh yeah, so my hash map thing would have worked as well, by the way. Let me implement that. If I can just implement that, then I'm kind of just happy with this problem. Um, and so this would just be for value for key value in nums. Wait, is this how this works? I don't think so. It's a frequency thing, right? For item in my list, I don't know why that wasn't on the top of my head. This would be if I already had a map. It would loop through it. So it would just be for item in nums if wait actually this is the same time complexity now. This is the exact same time complexity, right? Butchered that. Ooh. Oh my God, I'm an idiot, bro. A set you can't have duplicates, right? Wait. Oh, in for a list and in for a set or dictionary is different. Oh, so you just do like a for I in nums if I in scene values because the lookup time. So if it's in there, then you just return I. Else you would just do the scene values dot add I. Yeah. What was theirs? Nums dot sort. For I in range. If nums at I equals the next one, return. Yeah, that's also pretty good. Hash set, it's the one I did. Okay. That one should be kind of marked easy. I think that's the quickest I've done one in a while. Again, because it was a list. It wasn't actually a linked list. LRU cache. I'm actually in um uh, uh I'm actually in my I was talking about at the beginning of this video my project for how computers work. Um actually like last class we were learning about like least recently used within cache um and like how to like overwrite like values that were least recently used in that process. That's actually kind of cool. Yeah, literally this. You just fill up like the space you have. So this is like, the least recently used because you added that first, so it'll overwrite that, and then it'll just like keep overwriting. Um, yeah, that's cool. Okay, so we should initialize the LRU capacity. We should return the value responding to the key. So down here, what's this format? So get just gets us the value corresponding to the key. So someone calls get with a key and you give them back the value, correct? And then the void put update value of the key if the key exists otherwise. Okay, so that should just be a map, right? That's what we just did in the last question. A key is considered used if a get or put operation is called on it. So we input a string. That's so weird. So we input a string and then they pass through the value of 2. Okay. But that's how big our cache is. Then we do a put operation where we have the key of 1 and the value of 10. So we've now cached a key of 1 and a value of 10. Then we do a get 1, which will return 10. Then we have a put of 2 and 10, which would just put 2 and 10. Then we should put 3 and 30, which would overwrite 1 and 10, right? Oh, whoa. It actually shifts, it kicks one out, shifts it back, and puts the other one in. And then when you do the get 2, it gives us, and then when we get the get 1, there's no key, so we do it not found. So this is definitely going to be returning -1 default. Um, this, I won't lie, I never really get how def init works. So the only thing I'm going to ask right now is for this to don't solve this question, but explain how I can implement the first function here. I know I'm getting the cache size. Whoa. Initialize the cache with a specific capacity. Yeah. Mm-hmm. Self capacity equals capacity. Self cache is a dictionary. Okay. So, um, right. Okay. I won't lie, I've never used a doubly linked list before. So it just means you can go back easily. So there's a dot prev. Okay. Okay. So I think it's drawing time because this one's a little okay. So let's say for instance, we're passed through a value of 3. So we can have 3 spots in our would be dictionary, right? Couldn't um how to define, can you do that? I don't think it actually matters. Um Anyways, so we have this. Um this is our dictionary. That's weird though. Well, these are all dot selfs. So do I need to define? I won't lie. I'm like kind of like I understand what I have to do. But, like I don't. So this is an array of a cache and a capacity. So the get operation is for I in range length of the cache. If self.cache at I0 equals key. I won't lie, I don't get this. Okay, so this is where they actually make a node class. We have the previous and next and the key and the value. We have the capacity and we have this. These are nodes with a key and a value. It's a Twitch interview question. Okay, so in a remove function, the previous, just a variable named previous is equal to the node.previous. And then, so you're making temporary nodes, and then you're saying previous.next is equal to next? What? Oh, wait. Next is equal to the node.next. Okay, I see. I'm watching the video on this one.
To like the video, it supports the
My
channel a
God.
lot. So this is definitely more of a design problem than an actual algorithms problem. So we have some kind of cache that's going to store values. It has a capacity, so it's fixed size. And we want to be able to get values from this cache based on a key value. If that key value exists, then we'll return the value that it corresponds to. If it doesn't exist, the default value we want to return is -1. And if we're getting values, we also need to be able to put values into the cache. We're putting them in based on key value pairs. And there's a lot of edge cases, and they explain a bit of them to us. If the key already exists in the cache, then
Okay, I
say we're
understand the
putting
question.
a pair of 1, 1.
Yeah.
To like the video, it supports the need to kind of remember, right? The capacity is 2 in this case. And the next operation is put. So we're putting a pair of 1, 1, key 1, value 1, and the least recently used. So we got to kind of remember in what order are we adding these values in. The next one is another put operation, and we're putting 2, 2. Of course, for these first three,
Okay, I understand
and we
this.
know,
I'm just trying to see
how
because
can we know instantly what the value is when the key is 1? Well, the easiest way to do that would be with a hash map, right? So we're going to use a hash map to instantly look up the value of every key. We can, of course, do this in constant time, and we know that the size of this hash map doesn't need to exceed our capacity, so we can have only 2 values here, right? So for the key value, we can use the same value that we use for each of our nodes. And for the value, we could also do the same thing. We could use the same value that we use in our nodes, but I'm going to show you why it's going to be a little bit better for us instead to have the value be a pointer to the node itself. And we can do the same thing with the second node that we inserted as well. So for key value 2, we're going to point at this node. So now finally, when we call this get and we ask for the key 1, we're going to return the value 1 that's over here, which is exactly what the output tells us.
Wonder why you want to
So since we
have a pointer.
used the get
I don't see any
operation to
situation
get
where you
this
wouldn't
one,
just
we
have
went
the
to our
value in the hash map.
and we found this value and then we returned that value. That makes this the most recently used value, and this is the least recently used value now. So I'm going to keep track of the most recent and least recent by having a left and right pointers, right? So this left side is going to be the least recently used, and the right over here is going to be the most recent. So therefore, we're basically going to be swapping these two nodes, right? And so this portion of the problem is starting to keep the ordering of these. It looks like we're going to need a linked list. And not only a linked list, but a double linked list. Because remember, we can easily look up where these values are, but if we want to also reorder them quickly by for example, every time we use a get operation, we want to take this value and then move it over here because it was the most recent. And so now we're going to reorder the two nodes. So now this is the least recently used and this is the most recently used. And since this is a doubly linked list, we need the pointers to be connected. Of course, the hash map won't really need to be updated because these are pointers. They're already going to be pointing to the correct ones, and I'm not going to show that. And now we can get to the most interesting operation, the third put. So we're putting a third value, key value, 3, and since 3 is greater than our capacity of 2, then we're going to have to remove the least recently used value, and convenient for us, we know exactly what that value is. So first, we're going to end up updating these pointers to make the least recently used 1, 1 and get rid of this. And of course, we want to replace that 2 since we know it's the least recently used. We want to replace it with the new key 3. And now we also want to update that pointer. We want it to point at the new node. And since the new node 3, 3 is the most recent, we're going to put it over here, 3, 3. And the pointer is going to point here. This pointer is going to point here, and there's going to be a double link between them.
Like the actual concept of this is quite easy. I don't know why though. I can't follow this in code that well.
We're going to have a hash map where the key of the hash map is going to be the same key that we get from the input, and the value is going to be a pointer to the node.
Like just working with a double linked list, nodes,
and it's going to have
hash map, like all at the same time. It's a little.
Previous pointer and a next pointer. And
I haven't done enough leak code for this to be like
these are also
technically sound enough.
Because we want to have pointers. We want to be able to instantly know what's the least recently used and what's the most recently used. So these are going to be dummy nodes pretty much. So getting into the code, remember we're going to need a node. So before we even write this LRU cache class, let's make a...
I'm kind of going to do this by the side because this is just something that I need to learn. So outside of our class, let's see if I can just do this before he does it. It should just be a, is it a class node?
Another class for that node?
Yeah, so it's a class node. I know that we need, we need the value, the previous, the next, in the head. Is this a self or a...
And remember, each node is going to have a key value pair.
Okay. So we have self, we have a key, and we have a value. So self.key is going to just be equal to whatever we pass through as the key. The self.value is also what we pass through as the value. Then we have a self.next, which would be equal to none, right? And like a self.previous. These should probably be switched around. Is equal to none. I think that's what that looks like.
We're gonna get those. We're gonna initialize those. And we're also going to have 2 pointers, one for the previous node and one for the next node. And they're both going to initially be set to null. Now when we actually get into the LRU class, we know that the capacity needs to be stored because we want to know if we ever go over that capacity. We also need a hash map, and I'm going to call that our cache. And remember, this is going to map the key to nodes. And before we even have any values in our cache, we want to have a couple dummy pointers, a couple dummy nodes, which tell us what are the most recent and least recent
okay. Head and tail are fine.
Values that we added. So we can just.
But he won't. Yeah. So you want a node of 0, 0.
Initialize these to 0 for the default value, so 0, 0. And initially, we want these nodes to be connected to each other because if we're putting a new node, we want to put it in the middle between left and right. And we can do that with some point.
So like this idea was so self.left dot next, self.right dot previous.
Pointer stuff. So left.next is going to be right, and
so you're just saying that the left node is pointing to self.right dot?
right dot
Okay, I thought he was going more. Okay, that makes sense. So we have a self dot, not left. I want the head to be my left, so head dot next and self dot tail dot previous. Is going to be equal to self dot right and self dot left. But tail. Wait. Head, tail. Okay.
Previous is going to be left. And remember, left is going to help us find the least recently used. And
I should also do what he's doing here and make a note of
and right is going to be most recent. So now let's start with our get function because it's mostly straightforward. If the key exists, so if the key is in our cache, then we can return that value, right? So we can return self.cache of key. Now this tells us the node, remember, because each key is mapped to a node. So to get the value, we can just do .val. And of course, if it doesn't exist, they wanted us to just return -1. Now the only thing we're forgetting with this.
so if the key exists in our cache, then we want to return the value at that key, which is a pointer to the node.
This get is that every time we get a value, we want to update it to the most recent. So to help us with this part, I'm actually going to write a couple helper functions. So I'm going to write a remove and insert helper function. And these helper functions are going to be applied to our linked list. So we're going to pass.
Okay. Follow your lead. Def remove self and node.
In the node that we want to remove from our doubly linked list. And I'm also going to write a function to insert into our linked list. And when we insert, we're going to insert at right. And the remove is just going to remove from the list. So these are basically going to be pointer functions. We're going to be manipulating some pointers from our left, from our right, and doing some stuff. So I'm not even going to worry about that. All I know is that we have a helper function that can remove any node from our list and a helper function that can insert any node at the rightmost position of our linked list. So since we're getting, what we want to do to our list is take this node, self.cache of key, and remove it from our list. And after we remove it, then we want to reinsert it at the rightmost position. So we can just do self.
Okay. So not only do we want to return this, we want to remove it from our list. We want to remove cache value at the key and what are we inserting?
And looking at this, get isn't so bad.
If we're getting a value, oh, that's pretty smart. You remove it and then just to reinsert it, but it'll insert it at the tail, so you know that that's the least, recently used. That's quite smart.
As long as we fill out these two helper functions for us. So now when we actually look at our put function, let's remember that if we have a key that's already in our cache, that means...
Okay, if we already have a key that's in our cache,
a node already exists in our list with that same key value. So before we can insert this new key value pair, we want to remove from our list. So we can get that node by getting our cache and using the key value. So these helper functions are definitely coming in handy for us. So now we can create a new node with this key
with the
value
key
pair.
value.
So node, key value.
New node with our
And
key
we can put
value.
that in our hash map.
So
now our hash map has a pointer to this node, but remember that's not enough. We also have a doubly linked list, so we need to take this node and insert it into our list. So insert and just pass in the node, which is
self.cache at that key is going to be equal to that. Okay, and then
the key value. So the node is stored here, and we pass that node into our insert function. Okay, so we just inserted a new value, but remember, we have a capacity to worry about. So every time we insert a value, we got to check, does the length of our cache now exceed the capacity? If it does, this is the part where we're gonna remove and delete or evict the least
self.cap. Self.capacity.
recently used. So we're going to remove it from the list, the linked list, and delete the LRU from the cache or the hash map. So how do we actually find the node for the LRU? Well, this is why we have our left and right pointers. Remember, the left pointer is all the way at the left, and it's going to tell us what the least recently used was. So left.next is always going to be the least recently used. And so first, we're going to remove it from our linked list by just passing in the node. And we're also going to delete it from our hash map. So self.cache. And we want the key of this node, which is actually stored in the node itself. This is why we didn't only store the value, we also store the key in our node class. So we don't have to return anything in put, but we do now have to fill out these two helper functions, remove and insert. So if you have 3 nodes and you want to remove the middle node, what do you do? Well, you take this pointer and move it over here.
Yeah, I was going to say. You just set this equal to this, right?
And you take this pointer and move it over here. So this stuff
is for
no
doubly
longer
linked list.
And we have removed the middle node. This is going to be referred to as our previous node. This is referred to as our next node. So when we're writing this function, node is going to be the middle node, so we want to get the previous and next node.
So node, so for removing, then we want to...
nodes of node, so we can...
So the previous and the next nodes are going to be equal to... Oh, I see why he does that. So these are going to be equal to, for here, we want the previous one. I mean, it's just node.prev, is it not? Node.next.
And just get the pointer, so node.
And then if we actually want to remove this, we have to set the node.previous to point to node.next, right? So, I mean, it would be something like node.previous is going to be equal to node.next. Or there's more to this.
Previous node.next.
I see what he
All we want
says
to
here.
do is say that previous.next
Previous.next. Here, previous.next would be the node itself, though, right? Oh, previous.next is going to be equal to next. And next dot previous is going to be equal to this
should be updated, and next dot previous should be updated. These are the 2 pointers of the next and previous nodes. So previous dot next should be next. Next dot previous should be previous.
Yeah.
So now node is no longer in between previous and next. The last thing we need to do is fill out our insert function, which what we want it to do is insert a node at the rightmost position, right before our right pointer.
Do we have a dot left is actually dot tail? Do I do this anywhere else? I don't think so. But I have a self dot headed and tail because
So let's say this is our right pointer. We want to insert right here, and this is going to be our previous pointer. So when we have our new node that we're trying to insert, what we want to do is take this pointer and reassign it to that, this pointer, and reassign it over here. And we also want this node to be connected to its neighbor. So we're going to have the next pointer over here and the previous pointer to be here. So in this case, our previous and next pointers we can get by using our rightmost pointer.
right. So wait, I have this all messed up, don't I? In my head. So it's, yes, it's this I want to be head, and then here this will be tail. So previous and next here is going to deal with
So
tail.
self.right.previous
Self
and
dot tail dot
self.right.
previous.
Now we want both previous and next to point to node, so we can do that like this. Previous.next is going to be equal to next.previous, which is going to be equal to node. They're both pointing at node. Node has been inserted in the middle of them, and node.next and node.previous also need to be assigned to
The current next of the node and the previous of the node is going to be it's going to point to next and previous.
Next and previous. So this is quite a lot of code, about 44 lines with some space and comments in between. But
Yep.
this is how you get the most optimal.
There's probably an error in here somewhere. I know there's just gonna be so many mess ups because of that. Oh my. Nice. Yeah, it's a hefty problem. That's definitely the longest leak code, like amount of code.
Optimal solution for this problem. And of course, I had a bug, so I misspelled something. I'm really hoping that's the only bug here because I do not want to search for a bug in these lines of code. Okay, so we got it to pass. So I hope this was helpful. If you enjoyed,
Yeah. um. Yeah, I really that was a good question. I enjoyed that. Make some notes on it real quick. Um, make some notes on everything actually. I should have been doing this throughout everything. This I want to take note on that I still need to implement my um, non-static database and incorporate it into main. Having a code, straightforward. Uh, I think that's what I'm taking away from that. Um, what else did I take away from that one? Not this here. Uh, just a lot of just a lot of previous and next swapping. Um, I guess using nodes, experience using nodes within a hash map. Okay. So, how long were we going? A little over 3 hours. Nice. Good session. Yeah, I still need to look at this um tonight. I want to go over it and talk with my one of my group partners. I still really need to go over SQL because I have not done enough work, and so today I was just kind of leaning on ChatGPT to explain what was happening to me. So that I'll still have to look at. Um, Other than that, not much else that I want to to say here. Um, I'll be back tomorrow. I need to do a lot of internship applications today, um, and this week because I've kind of been slacking um, on that, and, and yeah. So yeah, bye.